The exploration of the Moon has been a central aspect of human space exploration efforts since the late 1950s. It began with unmanned missions aimed at close-up observations and eventually led to manned landings, most notably the Apollo 11 mission in 1969, which marked the first time humans set foot on the lunar surface. These missions have significantly advanced our understanding of the Moon, laying the groundwork for future exploration and potential resource utilization. The journey to the Moon started with probes such as the Soviet Lunar series and the American Ranger and Surveyor missions. These initial explorations provided valuable data on the Moon's surface and environment, essential for planning manned missions. The Apollo program represented a series of missions that not only demonstrated human capability to land on and return from the Moon, but also conducted scientific research on its surface. The collection of lunar rocks and soil has allowed scientists to study the Moon's composition, geological history, and the processes that shape its surface. In recent years, interest in the Moon has been renewed, with missions from various countries aiming to explore its surface further, identify resources, and test technologies for future lunar bases. These efforts underscore the Moon's importance as a stepping stone for deeper space exploration and as a potential site for scientific research and resource extraction. The governance of lunar activities is informed by international treaties, primarily the Outer Space Treaty of 1967, which establishes that the exploration and use of outer space shall be carried out for the benefit of all countries. While no nation can claim sovereignty over the Moon, the treaty does not preclude the activities of private entities. This legal framework creates an opportunity for the private sector to participate in exploring and potentially mining lunar resources. There are compelling reasons to consider lunar mining. The Moon harbors resources such as water, helium-3, and rare earth metals 4, which are essential for supporting sustained human presence in space and for advancing technologies on Earth. Water ice, found in the permanently shadowed craters of the Moon's poles, is not only crucial for life support, but also can be split into hydrogen and oxygen, key components for rocket fuel. Helium-3, an isotope rare on Earth but more abundant on the lunar surface, presents an almost ideal fuel for future nuclear fusion reactors, offering the promise of clean, safe, and efficient energy. Rare earth metals, vital for electronics and renewable energy technologies, are also believed to be present in higher concentrations on the Moon than in Earth's crust. Estimates suggest that the Moon's polar regions contain millions of tons of water ice. The exact quantity of helium-3 and rare earth metals is less well defined, but is believed to be significant enough to warrant the interest of scientists and industries alike. The potential value of these resources is staggering, with some estimates reaching into the trillions of dollars, highlighting the economic implications of lunar mining. The utilization of the Moon's resources could revolutionize industries on Earth. Water extracted from the lunar surface could support life and fuel production for space missions, reducing the cost and increasing the feasibility of long-duration space exploration. Helium-3 could be the key to unlocking clean fusion energy, drastically reducing our reliance on fossil fuels and mitigating climate change. Rare earth metals could meet the growing demand for high-tech devices and renewable energy solutions. Given the vastness of the lunar environment and the initial estimates of resource availability, the Moon's resources could support human and technological needs for centuries. However, the sustainability of lunar resource extraction depends on the development of responsible mining practices, ensuring that the benefits are long-lasting and do not adversely affect the lunar environment. The transition from theoretical exploration to practical extraction on the Moon necessitates innovative engineering solutions. The forefront of this endeavor features technologies such as 3D printing, robotic miners, and specialized facilities for resource processing and storage, paving the way for sustainable lunar mining operations. 3D printers are set to play a pivotal role on the lunar surface, enabling the construction of tools, habitats, and infrastructure using local materials. This reduces the need to transport materials from Earth, significantly lowering costs and making the establishment of a lunar base more feasible. Robotic miners are expected to be at the forefront of lunar excavation. These autonomous or remotely operated machines are designed to navigate the harsh lunar environment, extracting resources with precision and efficiency. Their development is a testament to the blend of science fiction and reality in our quest to harness the Moon's potential. The extraction of helium-3 gas, a valuable resource for future energy production, necessitates the creation of specialized production and storage facilities on the Moon. These facilities are envisioned to process and store extracted helium-3, readying it for transport back to Earth or use in situ for powering future lunar bases. The discovery of water ice at the Moon's poles is a game-changer for long-term human habitation. Not only crucial for life support, this water can be processed into oxygen for breathing and hydrogen for fuel, supporting both the sustainability of a lunar colony and further space exploration. Efficient transportation logistics are essential for the success of lunar mining operations. The challenge lies in designing spacecraft and systems capable of frequent, cost-effective trips between the Earth and the Moon with minimal environmental impact. This includes innovations in spacecraft design, propulsion methods, and the utilization of lunar resources to fuel return journeys. As we contemplate the prospect of mining the Moon, understanding its physical characteristics and the potential impacts of such activities is crucial. The Moon, with a mass of approximately 7.35 times 10 to the 22 kilograms, plays a key role in Earth's natural systems, influencing tides and stabilizing our planet's axial tilt. Considering the scale of the Moon's mass, extracting resources at a rate of 1 metric ton per day would mean it would take around 220 million years to deplete just 1% of the Moon's total mass. This perspective highlights the minimal impact that responsible mining could have on the Moon's overall mass and, by extension, its gravitational pull. Even with continuous extraction, the effect on the Moon's gravitational mass and its position in space would be negligible. The Moon's orbit around Earth and its gravitational effects, including its influence on tides, would remain virtually unchanged. This ensures that lunar mining, at the scale currently envisioned, would not adversely affect Earth's natural systems. From Earth, the Moon has captivated observers for millennia. The possibility of visible changes due to mining raises questions about the aesthetic and cultural impact. However, given the vastness of the lunar surface and the scale of proposed operations, any physical alterations are unlikely to be discernible to the naked eye from Earth. The iconic appearance of the Moon in our night sky would remain largely unaffected by mining activities. The Defense Advanced Research Projects Agency, in collaboration with Northrop Grumman, is in the process of developing a concept for a lunar logistics system, referred to as a railroad on the Moon. This initiative, part of DARPA's Lunar Architecture Capability Study, or Lunar 10, aims to establish a network capable of transporting humans, supplies, and resources across the lunar surface. The envisioned lunar railroad is designed to support commercial ventures and the broader objectives of creating a sustainable space economy, involving both the United States and international partners. The system's development is indicative of the strategic interest in utilizing lunar resources and infrastructure to facilitate long-term human presence and economic activities on the Moon. Meanwhile, a new venture led by former executives from Blue Origin, named Interloon, is focusing on extracting a rare isotope of helium from the lunar regolith. This isotope has potential applications in advancing quantum computing and, eventually, fusion power technologies. Interlune's approach includes the development of compact extraction units, roughly the size of a sedan, alongside other necessary hardware. These units are intended to enable the scalable extraction of lunar resources, representing a significant step towards the practical utilization of the Moon's materials for high-tech applications. The efforts of Interlune highlight the growing interest in and the technological strides towards the exploitation of lunar resources for their potential benefits in scientific research and energy production. As we edge closer to the reality of mining the Moon, it's imperative to address the ethical and legal frameworks that govern such endeavors. At the heart of space law is the 1967 United Nations Outer Space Treaty, which set the foundational principles for international space activities. This landmark treaty, ratified by key spacefaring nations, declares that outer space, including the Moon, is the province of all mankind. It stipulates that no one country can claim ownership of the Moon or its resources, ensuring that space exploration is conducted for the benefit of all humanity. However, the treaty primarily addresses the actions of nations, leaving a grey area when it comes to private companies. As of now, there's no explicit international law preventing private entities from claiming rights to resources they might extract from the Moon. This ambiguity has opened the door to potential future claims by private companies on lunar resources. The prospect of lunar mining operations introduces the potential for political disputes over resource rights and extraction privileges. As companies and countries navigate this new frontier, the need for updated agreements and regulations to prevent conflict and ensure equitable access is clear. Should private companies successfully establish mining operations on the Moon, they could gain significant control over resources previously beyond humanity's reach. This scenario echoes our opening contemplation. The unfolding lunar gold rush not only promises scientific and economic benefits, but also poses questions about who has the right to exploit these celestial resources. The expansion of human activities to include lunar mining brings forth several ethical considerations, each with significant implications for our future. Firstly, relocating industries known for their environmental impact from Earth to the Moon poses a unique solution to pollution. While beneficial for Earth's ecosystems, it raises questions about our responsibility to extraterrestrial environments. The Moon's surface holds critical scientific value, offering insights into the solar system's history. Mining activities could jeopardize these sites, challenging the balance between resource extraction and scientific preservation. International competition for lunar resources necessitates clear regulations. The Outer Space Treaty provides a framework, but specifics on resource ownership and management require global consensus to prevent conflicts. Considerations of intergenerational equity also emerge, emphasizing the need to manage lunar resources sustainably. Ensuring that future generations have access to these resources is paramount. Finally, equitable access and benefit sharing from lunar mining efforts are essential. Developing inclusive policies that consider all of humanity's interests will be crucial in guiding ethical lunar exploration. As we stand on the brink of this new era, it's important to remember the collaborative spirit that has always driven human exploration. The Moon, our closest celestial neighbor, offers us not just resources, but a common ground, a place where nations and companies can come together to work towards a shared future in space. The journey ahead will require the best of our creativity, determination, and cooperation. But if we navigate this new frontier wisely, the benefits could extend far beyond the lunar surface, opening new horizons for all of humanity. Join us as we continue to watch, dream, and work towards turning the lunar mining vision into a reality. If you have enjoyed this video, click the subscribe button below, and don't forget to hit the bell icon to receive notifications about our newest videos. Your support fuels our mission to bring science and engineering closer to everyone.